So coming back to the deep composition graph from inzight, we're going to look just a little bit deeper at our residuals and just kind of discuss what they mean. So we've taken a look and we've decided from this particular example about our percentage contribution, who's got a bigger percentage contribution. So we've done all that work already in the previous video, but I want to look now specifically at our residuals. So see if I can scroll myself down a little bit. Remembering that residuals are what are kind of random events or one-off events or just sometimes things that we won't even know what happened, but it basically is the variation that says we don't have the exact same number of backpackers every single year in every single season, and that there's never any variation. Residuals are kind of what results in the fact that things are not always what we expect. So residuals are calculated on the computer by taking the raw data, subtracting the trend, subtracting the average seasonal effect, seasonal effect, and basically what you get out of that is the random noise. And again, with the residuals, this could be things like an Ebola outbreak or a shark attack or bad weather, or possibly no reason at all. It's just a random thing that happened. But what we're going to do is take a look at them, and we want to decide if it's bigger than 10%, it's interesting, and you might want to investigate it. Less than 10%, get my N in there. Less than 10%, who cares? It's just random. Okay, so we need to calculate the effect of the residuals and to find out these percentages above 10 or below 10% using the same ideas that we just did. So we need to remember that our raw range, looking up here at the red, our raw range is actually 37%. And again, that was the overall from its absolute max to its absolute minimum, that we had an overall range there of 37% occupancy. So we're going to compare that to what we see here for the biggest residual. So the first thing that you want to do is actually just look for the biggest residual that you see. And there's quite a few in here, many that you could pick from. Knowing that this 0 is the middle line, we're looking for the distance from the middle line up or from the middle line down, not from a top to a bottom necessarily, because these are all individual events. So if you chuck a ruler on there, you might discover that things are pretty similar, but I'm going to guess that this one is about average for the course or pretty high. So we're going to look at the difference. We're going to look at the difference between the 0 line and that peak there. And if you dropped a ruler all the way across, you'd probably find that it lines up with roughly 4%. So we're going to say that this is roughly 4%, the total distance from 0 to the top. Okay. So my biggest residual, and there might be more than one, so if you had a few big residuals, you could investigate a few of them. But I'm going to look at the biggest one first, and if the biggest one is not important, if the biggest one is less than 10, then none of them are going to be important. So I always look at the biggest first, biggest residual, and we're saying that it's roughly 4%. We get that off reading the graph again from 0 up. And then we're going to, so that was 4% above. We're going to do the same comparison that we've done before. Out of the total overall range that we had, which was 37% overall that it moves, so out of 37, we're going to take that 4% residual and put it on top and times by 100. And when we do this, we get 10.8% for the residuals. So a 10.8% effect here for the variation is actually right on that borderline. It's an interesting case here because it's right between being bigger than 10% and less than 10%, because we're not rating very precisely here. So I would say, yeah, this might be interesting. I might look at it and see, but it's pretty close. You might not actually be able to find anything interesting. If you go and research for whatever quarter that is, quarter 1, 2005, you might actually find no information about that at all. And you would just say, it's just random, I can't identify why. Or you might find that there was a really good exchange rate between Australia and New Zealand, and so a few more people came that summer than in previous summers. So that's what we mean by investigating the residuals. You'll take a look at the time frame of when exactly an event occurred, and go and do some research online to figure out if you can identify a reason or a cause for that residual. If there's any explanation that makes sense to you about why it happened. But again, for things that are less than 10%, there's no reason to investigate it because it's not going to be interesting, or even if it is, it's still such a small effect that we consider it just part of that random noise. And the reason we call it random noise is just signal word from, I don't know, historically we always use it, but it's just basically saying the random stuff that goes on that we don't pay any attention to. So, had my residual here been like 50%, I certainly would have wanted to go look and see what was happening. Maybe Air New Zealand offered free tickets from anybody from Slovenia and the whole entire country came over. That would be an explanation for why there was such a big residual. But for this one at 10%, I'll take a look and see, but it's probably not going to be anything interesting. And that's fine, you might not have an explanation for your residual. So again, if it's bigger than 10%, for instance a 50% residual, you definitely want to look at it. There might be a good reason for what happened, like the global financial crisis. But if it's less than 10%, it's probably just random, and we here could say, my biggest residual is 4% above, that's just around 10%, it's probably not interesting, just random noise. Or you could investigate it and find nothing and then say, it's just random noise. So that's what we're looking at when we're calculating our residuals and looking to determine whether or not we want to investigate them. And again, if your biggest one is below 10%, then you don't need to look at the rest. And I did want to clarify one thing on both of these. I should have clarified it on the other video as well. This example is good because we understand what's going on, but it can be a bit confusing because we're measuring it in percentages. So just keep that in mind. Often we're talking about number of people or dollars or sheep sales or kgs of something, and this one just happens to be about percentages. So this unit here that says percentage on the 27 and 76 and 10%, this is not reading 10% off the scale. This is saying there's a 10% percentage of the 37 total change. So this is different to say this is a percentage contribution of the variation versus reading a percentage straight off the scale. So just keep that in mind. You'll always get percentages here for these last numbers that we calculate, but it's not always going to be percentages on the scale over here. Right. So give a play with those. Feel free to ask questions if you've got questions about it. And look again at those notes that we've given you that I was referring in the other videos to see what more you can figure out.